Hey guys, it's Miss Landry, and I am going to be talking today about the chemistry of life. And I know it sounds kind of strange to talk about chemistry in a biology class, but I think you're going to see that understanding the basics of chemistry is going to really help you when we start talking about macromolecules. So let's jump in. So there are four. We're actually only going to get to two of the objectives listed here in this video. I'm breaking it up into two. So the first thing we're going to look at is what is the difference between matter, elements, and atoms. And then secondly, we're going to look at the basic structure of an atom. So let's jump right in. So let's start with the terms. So this should be a review for some of you. So if you had 8th grade with Kent, then we did go over some of this. But for some of you, it might be new, and that's fine too. Let's start by talking about matter. So what is matter? Well, matter is what makes up the universe. So everything is made up of matter. And to define matter, anything that takes up space, so it has to have volume, and it also has to have mass. If you have those two things, then you have something called matter. We're going to go into, at the end of this little slide here, we're going to talk about is air matter, and I'm going to show you that. Yes, indeed, air is matter. So what is matter made up of? Well, matter is made up of elements. As of today, I think there's 118 that have been discovered. 92 of them are natural. The rest have all been made in the lab. But basically, you've probably seen the periodic table of the elements. But these elements are individual things that make up matter. So you might have heard of some like gold or oxygen. I actually have a favorite. I love xenon and cobalt. Those are my two favorites. I don't know why. It's kind of dorky to have a favorite element, but I do. And what makes up an element? Well, elements are made up of atoms. Now, the term atom comes from the Greek word atomos, which means uncuttable, which means like it can't be divided any further. Now, we know that that's not true because I'm going to teach you about some subatomic particles, which are smaller. But if you think about atoms as being the smallest particle of an element that retains its chemical and physical properties, that is what an atom is. So if I were to look at an atom of gold, it would have all of the same chemical and physical properties as a big chunk of gold. So kind of think of like atoms as this small, those make up elements, and then elements make up matter, and matter makes up you. So yes, you matter. So let's talk about, is air matter? And I love this question because, when we think about it, it doesn't seem like it, right? Well, let's take a look. So look at this experiment here. So a student actually blew up two balloons, okay, and has them tied to a straw. So he blew them up, or she, with the same amount of air. Now notice that if you blow up a balloon, the first thing, which is taking up space, has already been taken care of. So yes, the balloon does have volume. So right there, we've got half of matter, okay? Now, in order to determine if it has mass, they let the air out of one balloon, and notice that the mass of the balloon still blown up has more mass, and so it pulls it down. So then yes, we have mass. So the truth is air is matter, and it's actually made up of quite a few elements. Most people think that the air that we breathe is mostly oxygen, and that's not true. It is mostly nitrogen. It's almost 80% nitrogen, about 20% oxygen, and then a bunch of other stuff kind of mixed in that makes up a tiny little bit here at the end. So yes, air has matter, and it is made up of many different elements. Okay, so let's clear that. Now we're going to talk about what does an atom actually look like. So, nope, sorry, we're going to talk about what your body is made up of, which elements. And I love this picture here. I like both of these. You're made up of lots of different atoms. I want you to know these four. These four are probably some of the most important in terms of mass in your body: carbon, hydrogen, oxygen, and nitrogen. And if you look at this picture here, oxygen makes up about 65% of the elements in your body. Carbon is 18%. Hydrogen is about 10%, and then nitrogen falls in at about 3%. Now, most of those are not kind of by themselves. If you think about it, oxygen and hydrogen together make up water, and that's about 62% of you. So that's a lot. Carbon, hydrogen, oxygen, and nitrogen are all found in proteins. Carbohydrates have C, H, and O. So we'll talk about all these different macromolecules. That's what these are called: carbs, lipids, proteins. We're going to talk about all of it. So I just want you to know these four. Those are the four most important for you to know: carbon, hydrogen, oxygen, and nitrogen. So that's going to make up, if we were to add all that up, what would that be? 75, 95. It's like 98 point something percent, those four elements. So okay, clear this out. Last thing we're going to talk about really quickly is the atomic structure, and I'm going to review it on the second video. So if you don't get it right away, that's okay. We're going to keep practicing. There are three subatomic particles you need to know. So this is the basic structure of an atom. The first thing that makes up an atom are called protons. Okay, so if you look at this picture over here, these little red circles with the positives are protons. Okay, they're found in what's called the nucleus. Now, I know we talked about nucleus in a cell. Similar idea. This is like the center of the atom, and it's where all the mass of the atom is. So we have in the nucleus, we have protons, which are positive. So if I ask you, where are protons found? They're in the nucleus. What is the charge of a proton? It is positive. Okay. In addition, we also have, neutrons. These are also found in the nucleus. And so let me get orange to kind of match the color here. These are neutrons, which you can see right here. These actually don't have a charge. So these we call zero or neutral, which kind of makes sense. Think protons, P, positive, neutrons, N, negative. Okay, so the only thing found in the nucleus are neutrons, which are neutral, and protons, which are positive, which means that the charge of the nucleus is positive because that's all that's in there. Something positive and something neutral. So the overall charge of the nucleus would be positive. The last thing is the electron. Let me get a blue pen. These are teeny tiny particles outside of the nucleus, kind of in a cloud around the atom. And to tell you the truth, most of the atom is empty space. But what's key about these electrons, and I'm going to close this, they're negative. Okay, so this is where a lot of chemical reactions occurs based on interactions of the electrons. So it's very, very important to know. Electrons found outside of the nucleus, they are negative. Protons found in the nucleus, they are positive. And neutrons found in the nucleus, they are neutral. That's it for this video. You have a little practice to do, so come on back when you're done and watch video number 2. Thanks, guys.